Okay, so I want to talk about the idea of what's known as set difference. So let's start off with two sets. So we have the set A, and it has the elements 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, and 6. So that's set A. Then if we take set B, so set B has all of the elements 4, 6, 8, and 10. So 4, 6, 8, and that should be a 10. So 4, 6, 8, and 10. We can use a Venn diagram and we can draw this. So we can draw two circles and represent both sets. Something like this. So we will call this circle here set A, and we'll call this circle here set B. So what we can do is we can label we can put our elements into these sets into the Venn diagram. So the first thing I do is look for the common ones. So we have 4 is common between both. So I put it in here. So 4. So remember, this is the intersection, this space in here. 5 is not common. 6 is common. So again, that will go in here into the intersection. So we have 6, 8, and 10. Okay. So then I'd start putting in the ones for 1. So 1 we put in here. That's 1. 2 goes in here. 3 goes in here. 4 we have in here. It's part of A and it's part of B. 5 will go in here. 6 is here. So we have 8 then is only in B, and 10 is only in B as well. So we've two sets. Okay, now what we want to think about is this idea of set difference. So we can use the symbol. So if I was to say something like this, so A slash B. So what this means is this is a set. And basically what you're talking about, if we remove from set A all the elements which are in set B, we have this here, which is known as A less B. And the way to kind of think about it as well is it's like you're cutting off you're including the elements in A, but you're cutting off the elements that are in B. So what would that look like? So A less B in this case. Well, if we were to color it in, let's say on the Venn diagram, it would look something like this. So A less B is going to be all the elements that are in A, and you're leaving out the elements that are in B. So A less B would be something like this. If we were to look at it on the Venn diagram. So let's just so you can see it would look something like that. So that's A less B. And if you were to list out the elements then in that, so this is going to be equal to, so this is going to be equal to, so it's going to be the elements 1, 2, 3, and 5. So essentially what you're doing is you're taking all the elements that are in A and you're listing them, but you're excluding any of the elements that are in B. So that's what it means by a set difference. So this here, it's what's known as A less B. If we had it the other way around, so let's say you had B less A, so what that's going to mean is it's going to be all of the elements that are in B excluding the elements that are in A. So if we were to think about what that would look like, so let's say if we just colored A less B in red, so it would look something like this. So just A less B. So we just all these elements in here. So imagine, so this is just red, and this one over here would be yellow. I'll just put it here. So just to recognize it. So what would that look like if we wanted to list these elements? So it's going to be equal to the elements 8 and 10. So this here, like this intersect in the middle, means A intersect B, which would be equal to the elements 4 and 6. So it's like an intersect. So you could color that in green here. Oh. It looks something like that. So this is what we mean by set difference. And this less symbol, it can be used in many different ways. So this less symbol, or this symbol here, it can be used in a whole host of different ways. So one thing we could do is we could do something like this. So if we had bracket A union B bracket, and then we could use the less than sign, less A intersect B. So what does this particular set, what elements are going to be contained in this set here? So basically what we're saying is A union B less A intersect B. So A union B, if we remember what this is, A union B is going to be everything. So it's all the sets in A and all the elements in A and all the elements in B. So this U, just think about union. Imagine you have two classes and you unite them together. The students are the elements within the class. Now you're going to have just one big class with all of the elements, with all of the students within the class. So first of all, if we think about what that would look like, so the set A union B will look something like this. So it'll be 1, 2, 3, 4, 5, 6, 4, 5, and 6, and then 8, 8, and 10. So that's A union B. So we've just basically taken the two sets and we've combined them together. A intersect B is this here. So it's all of these guys in here. So what we're saying here is we want A union B less A intersect B. So we want all of these elements, but we want to take out the elements that are in the intersect. So this is going to look something like this. So if we think about, so what are the elements that are in the intersect? So we have 4 and we have 6. So this here is going to be this, but we want to get rid of this 4 and we want to get rid of this 6. Okay, because these are in this, they're in the intersect, and this tells us that we want to get rid of that. So what's this set of elements to look like? It'll look something like this. So it'll be 1, 2, 3, 5, 8 and 10. 5, 8 and 10. So that's what that looks like. So it's just this here means less. Or you just or in other words, you're taking all of the elements that are in this set that's in front of this sign, and then you're including all the elements that are in this set, excluding the elements that are in the set that follows. So whichever way that may be. So that's what we mean by set difference. So there are sets, and then there are differences between those sets as well. So what we need is some way to kind of talk about that mathematically, and we use this symbol here, less than, and that's what we mean by this idea of this is what we mean by this idea of set difference. So hopefully that makes sense, and thank you for listening.